Hello, I was asked to do a couple problems here for 9.1 in Math 127. So the first one says to find the center, foci, and vertices of each ellipse. There's only one ellipse in this problem. That the equation describes: x squared plus 3y squared plus 8x minus 12y plus 1 equals 0. So the idea here is we have to complete the square. And I'll start by subtracting the 1 from each side. So we have x squared plus 8x plus 3y squared minus 12y equals negative 1. I'm going to group these. That'd be x squared plus 8x plus some blank plus, and from these I'll factor out 3 because that's the coefficient for the y squared. 3 times the quantity y squared minus 4y plus blank equals our negative 1 plus that first blank plus 3 times, see the 3 from here, 3 times whatever goes in this blank. 3 times the second blank. And we take this 8, half of 8 is 4. We should do it like this. 8 divided by 2 is 4. 4 squared is 16. Take that 4, so negative 4 divided by 2 is negative 2. Negative 2 squared is 4. And that'll give us x squared plus 8x plus 16 plus 3 times the quantity y squared minus 4y plus 4 equals negative 1. Check it out. It's negative 1 plus, this first blank is what was with the x's, the 16, and the second blank is going to be 3 because you have 3 times 4, we brought in there, 3 times 4. So we end up with x plus 4 squared plus 3 times y minus 2 squared equals, come on, equals negative 1 plus 16 is 15. 15 plus 3 times 4 is 12 is 27. I hope we're okay with that step. And then for an ellipse we want it to equal 1, so we'll divide everything by 27. So we'll have x plus 4 squared over 27 plus y minus 2 squared over 9 equals 1. So the center is going to be, see it's plus 4, so it'll be a negative 4, because x minus negative 4 is plus 4, comma 2. My a squared is 27. So a would be the square root of 27, which is 3 times the square root of 3. B squared is 9, so b is 3. Now, excuse me, my a squared is 27. And so a is 3 root 3, so my vertical axis has a length of, no, I shouldn't say that, not vertical, my major axis. Major axis has a length of 2 times 3 root 3, which is 6 root 3. Okay? So we're supposed to find the vertex, the center. I got the center. Oh yes, my c squared is going to be a squared minus b squared, and that's going to be 27 minus 9, which is 18. So c squared is 18, so c would be the square root of 18, which is 3 times the square root of 2. I hope we're okay with that. Now, I'm going to just draw a rough sketch of this, very rough. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay, so our center is at negative 4, 2. And so our vertices are going to be at -4 plus 3 root 3, comma, 2, and -4 minus 3 root 3, comma, 2. So going out either direction, 3 times the square root of 3. And our foci are going to be -4 plus 3 root 2, comma, 2, and -4 minus 3 root 2, comma, 2. So let's see, 3 root 3, it's going to be a little over 5 because square root of 27 is a little more than 5. So 2, 3, 4, 5. So we'll see out to there. And one, 2, 3, 4, 5 is a little further there. And as far as those foci are located, we're going to be having, let's see, square root of 18 is going to be a little more than 4. So 1, 2, 3, 4. I got to draw these a little higher, I think. 2, 3, 4. And then for, let's see, we have foci, vertices, and center. I think we found everything we need to find. We got the center, the foci, and vertices. But I just want to give people an image here of what's happening. We're going to go up 3, 1, 2, 3, and down 3, 1, 2, 3. This is what our ellipse would look like, something like this. But I know it didn't ask for us to find it, but I just wanted to draw it because it helps me to visualize it. So we have the center, the vertices, the foci. Okay, let's go on to number 33. It's a very similar problem for number 33. It's also a completing the square problem. We have 16x squared plus y squared plus 160x minus 6y equals -393. Excuse me, so if we have 16x squared plus 160x plus y squared minus 6y equals -393, you could factor that 16 out. You'd have x squared plus 10x plus blank plus y squared minus 6y plus blank equals -393 plus 16 times the first blank plus that second blank. So 10 divided by 2 is 5. 5 squared is 25. And -6 divided by 2 is -3. -3 squared is 9. So that means we're going to have 16 times the quantity x squared plus 10x plus 25 plus y squared minus 6y plus 9 equals -393 plus 16 times 25, which is 400, plus the 9, this 9 here. 16 times 25 is there, plus the 9. So the equation stayed balanced. 16 times x plus 5 squared plus y minus 3 squared equals, so that's -393 plus 400 is 7. 7 plus 9 is 16. And it's supposed to equal 1, so we'll divide everything by 16. And we have x plus 5 squared over 1 plus y minus 3 squared over 16 equals 1. So the number under the y is bigger, so we have a vertical major axis. A squared is 16, so a is 4. B squared is 1, so b is 1. C squared equals 16 minus 1, which is 15. So C equals the square root of 15. This says to graph the ellipse and determine the coordinates of the foci. So our center on this one is going to be at -5, +3. Our foci are going to be located at -5, 3 plus the square root of 15, negative 5 comma 3 minus the square root of 15. So that's, we add the c, we subtract the c. And the square root of 15 is just under 4. I think it's 3.83. And the vertices are going to be located at negative 5 comma 3 plus 4 and negative 5 comma 3 minus 4. It's negative 5, 7, negative 5, negative 1. Excuse me. And of course, for the minor axis, we're going to go out 1 from the center on either side. So negative 5, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Negative 5, 3 is right about there. And then we're going to go up to 7. So up 4 and then down. Yeah, 4. 1, 2, 3, 4. They're going to go out 1, and that way 1. So this is what our ellipse looks like. It's really flat, which is going to mean that the foci are pretty close to those vertices. So it's almost up there and down here. Okay. So that would be number 33. I hope that makes sense.